Good morning, ladies and gentlemen. So we continue on with graphing quadratics using the x-intercepts. We found the x-intercepts before, or when you were solving for x. Now we're going to translate that into graphs. So I need you to recall that intercept form is of the form y equals a times x minus r times x minus s, where r and s are the zeros, which are also called the x-intercepts. The x-intercepts of a quadratic relation are called the zeros, as we already know, and are also called the roots, which we talked about yesterday. We can graph a quadratic relation, or quadratic relation, that should not be an S, by finding the vertex, x-intercepts, and other symmetrical points. We'll factor y equals ax squared plus bx plus c down to intercept form. And we'll start with this first example of y is equal to negative 1x squared plus 6x minus 9 by finding the x-intercepts and the vertex. So to find the x-intercepts, we know that for any x-intercept, let y equal 0 for the x-intercepts. So if that's the case, then 0 is going to equal negative x squared plus 6x minus 9. So just like yesterday's lesson, we need to solve for x. So what I like to do is I like having my a value positive. So what I'm going to do is I'm going to divide everything, both the left side and right side, by negative 1. So that way I will get 0 is equal to x squared minus 6x plus 9. Hopefully, a few of you can see that this is a perfect square trinomial because the square root of x squared is x, the square root of 9 is 3, so the middle term has to be 2 times x times 3, which it is, but it won't be 3, it's actually negative 3. So therefore, the binomial I'm going to get here is x minus 3 all squared, because this is a minus sign here, gives me a minus sign here. Okay, so I need to solve for the zeros. So if I try to solve for the zeros here in this case, well, I need to have a number or two numbers that equal to 0. Well, remember, x minus 3 all squared is x minus 3 times x minus 3. What that is then saying is that, so either x minus 3 equals 0 or x minus 3 equals 0, but since it's the same thing, I only need to write it once. So what that tells me then is that if I add 3 to both sides, I have x equal to 3. So therefore, I only have one x-intercept at 3, 0. Now, let's think about this for a second. If I only have one x-intercept, remember, a parabola is a symmetrical U-shaped curve. Every point has a mirror image point except for the vertex. Well, I should have two x-intercepts or no x-intercepts, right? If I have two x-intercepts, then I know that I can find the middle. But if I only have one x-intercept, that means I must have the vertex. So since there is only one x-intercept, and by symmetry, that every point every point has a mirror image point. This must be the vertex. Has to be the vertex. I have no choice for it to be the vertex. So if I know where the vertex is, I'm going to plot it up here on my graph. Scroll up a little. So y to the sky, x to the horizontal. I'm saying the scale is 1. So that's an x. Wow. So when x is 3, 1, 2, 3, y is 0. There's my vertex. 3, 0. So now I need to start using my knowledge about quadratics to my advantage here. So in this case, if I look at my original equation up here, negative x squared plus 6x minus 9, my a value right here is negative 1. So if I have a negative, a value, that means I'm sad. If I'm sad and I'm negative, that means my parabola is going to open downwards. So first thing I need to write is parabola opens down because a is negative 1 and I'm sad, which means I'm going to open downwards. So not only that, but if my vertex is at 3, 0, my axis of symmetry equation is the x-coordinate of the vertex at x equals 3. So I can draw a dotted line, the mirror, like this. Okay. So now I need to find other points on my parabola. Points that are close to the vertex, to make my life easy. So if you think about the mirror being at 3, don't go too far from the mirror. Why not pick a value maybe 1 away from the mirror? So let's try x equals 2. So if we let x equal 2 in the equation of y, let x equal 2, let x equal 2, it's 1 away from the mirror. So how about I put this in a table of values? Maybe that might be easier. So there's 3, there's 2, y equals negative x squared plus 6x minus 9. So wherever, I know that when x is 3, y is 0. So when x is 2, so I'll have 2, 2. So it'll be y equals negative, then x squared plus 6 times x minus 9, which is 2 squared, which is 4, but the minus sign makes it, going to make it negative. That's 12. That's negative 9. That's negative 1. So this coordinate is at 2, negative 1. So the mirror image point is on the other side, 1 away on the other side, so it's 4, 1. 4, negative 1, negative 1, negative 1, negative 1. Sorry. So when x was 2, negative 1, mirror image point over here. Okay. Now, some of you might say, you know what, Mr. Michaud, I'm going to make my life easy. Why don't I just let x equal 0? Sure, why not? But you got to be aware what that's going to do, right? So that's 0 minus then x squared plus 6 times 0 then minus 9. Well, the answer is negative 9. So this coordinate is at 0, negative 9. Ask yourself, though, how far is, when x is 0, how far is x equal to 0 away from the mirror? How about I plot it? And maybe that's easier to see. 0, negative 9. So when x is 0, y is negative 9 down here. Here's 0, negative 9. You have to ask yourself, how far away are you from the mirror? In this case, you are 3 units away from the mirror. So you got to go 3 units this way. So that's 4, 5. That's at 6, negative 9. And now you can plot, now you can draw your parabola. Something like this. Now it's not very, wow. It's not very accurate because I probably should have picked a value like say 2 away from the mirror. And that's perfectly valid. I just chose let x equal 0 because I know somebody's going to say, you know what, why don't you just let x equal 0? It's only 3 away from the mirror. That's no big deal. 6, negative 9. So up here, so this is a mirror point. Wow. I can spell. Mirror point. And that's also quotations for mirror point. 6, negative 1. Okay, there you go. Next. Graph 2x squared minus x minus 6. So to graph it, you need to graph the x-intercepts and the vertex and then 2 other points. So if I give you this equation, if you're going to graph the x-intercepts, you need to let y equal 0, just like we did before. So 0 is equal to 2x squared minus x minus 6. So I see my a value is positive, so guess what? I know it's going to open up. Keep that out back of my head. First, I need to look to factor this trinomial. Does it have any GCFs? It doesn't, so I got to use my chart of A is equal to 2, B is equal to negative 1, and C is equal to negative 6. So I need 2 numbers that multiply to A times C, which in this case is negative 12, and add to B, which in this case is negative 1. So that's negative 4 and 3. So now I can substitute those values in for my B value. So I'll have negative 4x plus 3x. Well, it's still 0 is equal to 2x squared minus 4x plus 3x, then minus 6. Then factor by grouping with the first 2 terms and the last 2 terms. That's 2x. GCF here is 3. The binomial that I'm going to have in common will be x minus 2. And here, x minus 2 equals 0. So I'm going to have 2 binomials of x minus 2 and 2x plus 3. So x minus 2 equals 0, or 2x plus 3 equals 0. So opposite operations here. X is going to equal 2. So I have an x-intercept at 2, 0. While over here, I'm going to subtract both sides by 3 to get 2x equals negative 3. Then I'm going to divide both sides by 2. So x equals negative 1.5, or negative 3 over 2. So I have another x-intercept, in this case, at negative 3 over 2, comma 0. All right, now, once I do that, I can find now the axis of symmetry. So the axis of symmetry, I'm going to take my 2 x-intercepts, add them up. So it's 2 plus negative 3 over 2 divided by 2. Well, that's 2 over 1 because every whole number is divided by 1, but we don't bother writing it. So that'd be 4 over 2 minus 3 over 2, all divided by 2. So that's then going to give you 1/2 in the numerator divided by 2. Well, if you take half and divide it by 2, that's going to be a quarter. Because if you have 50 cents, I say divided by 2, that's going to be 25 cents. If you don't see that, pretend the 2 is over 1 and you have a fraction dividing a fraction, which means you multiply by the reciprocal. Therefore, the equation of the axis of symmetry is that x equals 1/4. So now that you know where the axis of symmetry is, the vertex is going to be at 1/4 something. In order to get that something, you're going to plug in x equal to 1/4 into the original equation. So 2x squared minus x minus 6, which gives you 2. 1 times 1 is 1. 4 times 4 is 16 because you square the fraction. Minus 1/4 minus 6. Well, 2 goes into 16 8 times, so I'm going to left with 1 over 8 minus 1/4 minus 6 over 1. Lowest common denominator between the 3 of them is 8. So that's 1 over 8 minus 2 over 8, and then minus 48 over 8, because if the LCD is 8, I need to multiply this fraction by 2. So 2 times 1 gives me 2. And multiply this fraction by 8. So negative 6 times 8 is negative 48. So therefore, the y-coordinate of the vertex is going to be at negative 49 over 8. So therefore, the vertex is at 1/4 negative 49 over 8. Okay. Hopefully that's okay. And finally, I think when I have you graph, it won't be anything that bad. So this time, I'm giving you the parabola, and I want you to, let's go scale of 1. I want you to tell me what the equation is. So here are the points I would give you. So this here is at negative 2, 0. You have another point over here at 2, 3, 4, 0. And I'm giving you a point at, oh, shoot. Sorry. Scale of 1 on the x-axis, scale of 2 on the y-axis. So 2, 4, 6, 8, 10, 12, 14, 16. This point is going to be at 2, 16, and my parabola is going to be graphed like this. Oh, right there, like this. Okay? So I know it doesn't look like it, but I can't draw, okay? I'm a math teacher. I'm not an art teacher. So you can't tell exactly where the vertex is, so I'm forcing you to use intercept form, just like we've done before, somewhat. So I want you to write this equation in standard form. So let's use what we've got to our advantage. We know what the equation is in intercept form. We know where the x-intercepts are located. So we're at negative 2 and 4. So if r is negative 2 and s is equal to 4, so it'll be x minus negative 2 and x minus 4. So I'll have y equals a times x minus 2 times x minus 4, which will turn into y equals a times x plus 2 and x minus 4. So I have that. Now I need to plug in a point that's on my parabola. This point, I forgot to mention, is at 2, 16. 2, 16. So when x is 2, y is 16. So that is a times 2 plus 2 times 2 minus 4. That's 16 is equal to a times 4 times negative 2, which is 16 equal to 4 times negative 2 is negative 8, and times that by a. Solving for a, I divide both sides by negative 8, so my a value is negative 2. So my equation in intercept form is y equals negative 2 times x plus 2 times x minus 4. I want this, though, in standard form, so I'm going to FOIL first to get negative 2 times x squared minus 4x plus 2x minus 8, which gives me x squared minus 2x minus 8, like that. So now I need to distribute the negative 2, if I can actually draw, negative 2 to all three terms, like this, so that it is now in standard form. So I get negative 2x squared plus 4x plus 16, and that equation now is in standard form. Your homework is right here. Yep, there's the bell. So, this here. This is your homework. All right, folks, thank you very much. Have yourselves a good day. Please come with questions tomorrow if you need it.